Welcome back, friends. It's me, Ardalis. And as always, if you enjoy this video, I would appreciate it if you would give it a like and subscribe if you want to get notified when I have more content like this to share. In this short video, we're going to answer a couple of common questions like when should I use validation, or when should I use guard clauses or exceptions? And related to that, when does it make sense to use something like a result type or a maybe type? All right, so we're going to answer these in the context of some real C# code here we're going to dig right into. I also have an article on this. I'll leave a link to the article in the description. All right, so I have an API here that is part of my clean architecture template. So if you look for Ardalis clean architecture in NuGet, you can get this template, and then you can just do a .NET new, follow the instructions, and it'll create an application that looks a lot like this. So out of the box, there's a sample of contributors, and contributors are just people that have a name and an email address, and there's a little bit of validation on these types. So when you go to create a new contributor, like this one right here, we're going to say, here's Jay, and their email is test@test.com. I'm going to send this request, and I get a bad request. And when I look at the bad request, it says the length of name must be at least 2 characters. You entered 1 character. This is the type of validation that we're talking about. This is not something that's exceptional. It's pretty normal that users might give you data that doesn't quite conform to what your requirements are. That's not an exceptional occurrence. That's not something that deserves to be handled with exceptions in your code. So the place for validation should be as close to the user interface as possible. In the case of an ASP.NET Core app, that's going to be wherever HTTP requests are entering into your application. When we're looking at this web API, it's using this create endpoint here. We're using the fast endpoints library for this. And so this is going to map to a particular request. In this case, it's going to be a post. It's listening to /contributors, which is exactly what we just posted to here. As you can see, we did a post to the /contributors endpoint. Now, inside this handle method, all we're going to do is pass this on to our use cases layer using mediator and creating a command. But before it even gets to that, we're going to do some validation. Now, how you do validation is something that will vary quite a bit between applications. I strongly recommend that you find a way to do it in a way that is a cross-cutting concern that doesn't result in a lot of conditional logic inside of each one of your endpoints, right? So you can use the built-in model validation that ASP.NET Core has supported for quite a while, or you can use something like fluent validation, which is what I'm using here. So looking at the Solution Explorer here, you can see that the create endpoint has a request, and this is the DTO that it expects to have sent to it. In addition to having the actual data for the DTO, which is just a name, it also has the route here so that you can reuse that in your tests. It has a response. This is what you expect to get if this thing is successfully created. And so here it's just going to have an ID and a name at that point. And then it also supports having a validator. Now this validator is using fluent validation, and it inherits from the validator of T, and in this case, it's validating a request, a create contributor request. And you can see the rules for such a request dictate that it can't be empty, and it must have a minimum length of 2 and a maximum length of our data schema constant default name length, which in this case is going to be 100. So what that means is that if I try and put in a name that is 1 character long, or 0 characters long, or 101 characters long, all of those should fail. And it also means that we can easily create some functional tests that verify this. And so here you can see I've got in my functional tests project a couple of things for contributor create that are verifying this exact behavior. So I create a request with a name of just A, and I expect that I'm going to get an error that says the name must be at least 2 characters, and you can see this test is passing. Then I do the same thing for 101 character name, which I'm just going to do with this pad left here. And so it's going to be just all A's for 101 characters. And again, I'm going to see the error message is going to say name must be 100 characters or fewer. And by the way, you entered 101 characters. Again, that test is passing. So this is where validation makes sense, is at the edge of your application. Once you're inside your application, though, that's where bad input isn't a question of users entering the wrong thing. It's a question of developers making mistakes, developers writing bugs, developers forgetting to validate something, right? So once we get into the use cases layer of our application, we've got a contributors create use case, and it has a create contributor command. That's the same one that we were just creating, and it has a handler. And in this case, the handler is just working with my domain model to create the item that is in question here, the contributor. All right, so we're just going to new up a contributor here, passing in the name, and then add it to the database, and then return back the ID of the item, and then that's what the calling code is going to use to do its job. Now in here, I don't have a whole lot of validation going on. I could add some guard clauses here if I wanted to, and that wouldn't be totally out of place. However, in this case, I might want to use a validation because it would be really easy for me to leverage the behavior pipeline that Mediator affords so that I could do validation in a repeatable way that wouldn't require me to write separate if logic for each one of these. And so because this is a handler and it's part of a design pattern that Mediator uses, where you're able to have the same thing as in ASP.NET Core middleware, it's called the chain of responsibility design pattern. We are going to have handlers that call the next handler and call the next handler until it reaches a terminating handler and then it returns. Now, in this case, this one is the terminating handler. It's returning, but there's nothing to prevent me from adding handlers in front of this one. And in fact, in this sample application, by default, it has a logging behavior that is in front of this and takes care of logging what was called and what was passed into this thing, what was the command and what was the value of it. In addition to that, and I'll show you in another video, you could add a validation behavior that will add validation to the pipeline for all of these commands without you having to touch each one individually. All right, but it's working with this contributor entity, and that contributor entity is part of my domain model. And if I'm doing domain-driven design, I want to make sure that domain model is always in a valid state. And so that's a place where it is going to be important that I work with things to ensure that I don't have bad data coming into my system. And so here we're using the new C# 12 feature of primary constructors. And so contributor takes in string name as a constructor value, does not have a separate constructor. And so when we assign name from that argument, we can use a guard clause there to verify that it exhibits certain qualities. In this case, I'm just checking that it's not null or empty. I'm not going so far as to check that it's in a valid range. We could do that, but it would be a little more effort here. Now on the update method, we're going to do the same kind of logic, but I want to show how you could also use another pattern if you have things that you would like to be able to return without throwing an exception. All right, so if I pass in a null name to this or an empty name, this guard clause is going to trigger and it's going to blow up and it's going to be an exception. Right now, that same thing is happening here in update name, where it's the exact same call, as you can see, right? This will throw an exception for that. But I've got this to-do item here saying I want to add some validation logic to change it. So I'm going to comment out this thing for a moment. And we're going to go ahead and look at what this would look like if we changed it to return a result. And so if we have a result, in this case, it's just a result, not a result of t, because we're still not returning anything. Now, because we're returning a result type, we have a way to return things that aren't a successful result. And that's the key thing that we want to have here. So the first thing we could do, instead of blowing up when the thing is null or empty, we could just return a result.invalid. And this will have a validation error that will say that the name is required. Then in addition, if the length isn't in the right range, we can do the same types of checks here. And we could say, if the length is less than 3 or greater than 100, we're going to return these validation errors instead. At the end, if it passes by those things we haven't returned, then we're going to want to assign name to be new name, just like Copilot is suggesting. And then if that happens, we can return a success result. And that makes it so that it's clear to the calling code that this operation completed successfully. Now, if I want to call this code, I can look at the result back and say, hey, if this was a result.invalid, then I want to return something to the user. I want to show them what the problem was. Otherwise, I can assume it was successful, or I can do a check to verify it was in fact a success. So I'll do some more videos about this result pattern later, but I did want to include it here just to show that there are ways for you to return something even from void methods like this, where there's not an obvious thing that you're returning from the method. You could just return this result abstraction instead of returning void. And then when you're using void, the only way you can communicate back out is either with an out parameter, which I generally don't prefer, or by throwing an exception, which isn't always the right way to go. All right, so I hope that cleared up when you should use validation or when you should use exceptions. The key thing to remember is that validation is targeting the user. It's meant to be visible to the user. I should remind you too that if you're going to use localization and return things in different languages or different locales, you want to make sure that you do that with all of your validation responses. So those things should be localized, but your guard clauses and your exceptions, those are designed for consumption by developers, right? So you don't necessarily need to localize those unless you have an international development team. If all of your source code is in English and everyone is looking at your logs is going to be expecting them to be in English, then it's perfectly okay for your guard clauses to only be in English as well. That does simplify things because you don't have to try and figure out how to use localization inside of your exception traces, which is not a trivial thing to do necessarily. All right. If you enjoyed this, again, please like and subscribe, share it with your friends, leave me a comment, let me know what questions you have or what topics you'd like me to cover. And until next time, keep improving. Thanks.